Good day, I am Carl Anton A. Calvio, and in this video, my groupmates and I will discuss all about indicator diagrams. So what is an indicator diagram? From the name itself, it is a diagram that indicates something, and in this case, it indicates the condition of the engine and its different components. The indicator diagram was first developed by James Watt and his employee, John Southern, to help understand how to improve the efficiency of steam engines. Engine indicator is the device used to take the indicator diagram. This can also be considered as the stethoscope for diesel engines. The indicator diagram is very important since it is used to know the combustion in the cylinder and also to adjust the engine. Indicator diagrams give efficiency of the combustion in the cylinder, condition of the running gears, irregularities in fuel pumping and injection, and for a lot of things. An example of an indicator diagram is shown in the slide. This shows the pressure and volume relationship inside the cylinder of an engine. To explain this, we'll first determine the values. Pmax is the maximum pressure inside the cylinder. PO is the atmospheric pressure. The VC is the volume of the combustion chamber, while the VD is the volume of the cylinder. S is the stroke. TDC is the top dead center, and BDC is the bottom dead center. IV is the intake valve. EV is the exhaust valve. The volume is measured in cubic centimeter. We have here the positive W and the negative W. This means that the positive W, work is done, and the negative W, work is lost. To start explaining, we will start with point A. The piston will now start to move down and the exhaust valve closes. So this is the intake stroke from point A to point B. After the piston reaches bottom dead center, it will now start to move up to point C or to the top dead center. And as it goes up, the intake valve closes, and before it reaches the top dead center, the fuel is injected, thus ignition. And as it reaches the top dead center, combustion happens. So the pressure greatly increases, which reaches point D. And from point D to point E is the power stroke, where the piston will start to go down because of the combustion. And because the volume increases, the pressure decreases. And before it reaches the bottom dead center, or point E, the exhaust valve will open. And in this part, work is done. So we can see that we have positive work. From point E to point A is the exhaust stroke. The piston will now start to move up to the top dead center. But before it reaches the top dead center, the intake valve will open to be used for the intake stroke. And then the cycle goes on again. The types of indicator diagram are the power card, the draw card, the compression card, and the light spring diagram.
The first type of indicator diagram is the power card diagram. So power card is taken with the indicator drum rotating in phase with piston movement. So in the diagram, we see that the atmospheric line is below the Pmax, so is the vertical line. And as you can see, the pressure in the diagram is slightly higher than the atmospheric line. So as the piston goes up, ay aangat din yung pressure, and if injected or bigyan ng injection ay mas papalo pa ito pabalik sa exhaust. So power card is also called a banana diagram because it looks like a banana and inside it is the work done. So the main indicated pressure or MIP is obtained from this diagram to calculate the power produced in the cylinder. And every cylinder of an engine has different power card, and it's there that you will get the data to compare or to say that it's in normal operation, or kung may nagde-deviate ba sa normal condition ay malalaman lang yun based sa ating power card data.
Draw card. Draw card is taken in similar manner to power card with fuel pump engaged but with indicator drum 90 degrees out of phase with the piston stroke. So, using the draw card diagram, we get a clear indication of the fault in exhaust, injection, and exhaust system. Even effects for improper setting of the indicator instruments are much clearer in this diagram. The area of this diagram gives us the main indicated pressure or total power produced for the system. Here in the draw card diagram, the pressure will rise as the pistons start to move up. Now, the maximum pressure to which air pressure reaches before the start of the combustion process is called compression pressure. So, this can be seen in the form of a small bulge in the diagram. Combustion starts and the pressure rises again and then falls gradually as the expansion and exhaust strokes start to happen.
Next is the compression diagram. It is similar to the power card when taking engine performance, wherein the indicator drum rotating in phase with the piston movement, or in other words, ang pagkuha nito ay sabay sa piston movement, just like an up-down movement. But the difference is that the fuel is cut off because we just want to know the compression pressure of the cylinder and the cylinder tightness. As you can see in the diagram, the highest point of the curve is the maximum pressure. Now, if the compression line and expansion line coincidence, it means that the indicator is correctly synchronized with the engine. Now, if there is a reduction of the line or the height, it means that there is a low compression. There is a low compression, it may be due to worn cylinder, faulty piston rings, insufficient scavenge air, or leaky exhaust valve.
The light spring diagram is taken with the same indicator instrument similar to the power card diagram. The only difference is a light compression spring fitted to the indicator instrument. The light spring allows the device to be operationally sensitive during the exhaust and the scavenging procedure, while the working pressure is much lower. The diagram shows the changes during the exhaust and scavenge processes to an enlarged scale, so this diagram is mainly used to monitor and detect problems during these processes. As you can see, in the diagram, there is a gradual cylinder pressure drop when the exhaust valve opens, until it almost reaches the pressure line and the scavenge ports open. In this part, the pressure increases as fresh air enters the cylinder, then drops as residual gases exit the cylinder. After scavenging, the exhaust valve closes, then the compression takes place and the pressure increases, then combustion is represented by the straight line, then back to the exhaust stroke. If there is deviations from the recorded values, there may be some faults in our engine, especially in the exhaust valves or intake ports.
So this is an indicator diagram. Specifically, this is a combination of the power card diagram and the draw card diagram. The power card diagram is this one like a banana, and the draw card diagram is this one like a mountain. So we all know what is the power card and the draw card diagram. In this diagram, the indicator diagram, it is used to measure the compression pressure and the maximum pressure, and also it is used to evaluate the ignition characteristics of the fuel oil.
Diagram irregularities may be due to indicator instrument itself or faults from engine parts or system. Diagram deficiencies due to incorrect adjustment of indicator instrument. So due to indicator instruments, if irregularity seems for all units, problem may be common like faults in fuel oil system, intake air, turbocharger, air cooler, exhaust, and etc. When the irregularity is confined to a single unit, problem could be of fuel injectors, fuel pump, exhaust valve, and etc. due to engine parts or system.
First, let's tackle about the early ignition. So based on the diagram, the abnormally high peak pressure of the unit is recorded at the top of the piston stroke, and it's because of early ignition causing combustion to start long before it is supposed to be causing. Also, extra pressure at the end because of early ignition. And it can cause a knocking sound which comes out of the engine due to heavy loads which is passed to bearings via running gear. So early ignition causes increased thermal efficiency of the engine, and also exhaust temperature reduces since the combustion starts long as it should be at its normal operation, causing shock loads and vibration which result in damage to the engine. And some of the causes are incorrectly absorbed or accidentally changed fuel pump timing cause of wear, damage or incorrectly set fuel valve of fuel injector, and undesired fuel quality and parts inside the cylinder are overheated. And now let's talk about the late ignition. So from the diagram of late injection, we see that from the normal operation, we have a delayed ignition creating less pressure. That's why the low peak pressure is indicated for the unit after top dead center. So based in the diagram, the combustion continued during expansion stroke, which give rise to incomplete combustion of fuel, loss of energy, elevated exhaust gas temperature for the unit, and black smoke at the engine exhaust, and this results to a reduced power of the engine due to incomplete combustion of the fuel and energy lost in the exhaust. So ang power ng makina ay mababa kung ikukumpara sa kailangan nito. And some of the causes are faulty fuel injector, poor fuel quality, wrongly timed or leaking of fuel pump, engine parts inside the cylinder are undercooled, and incorrectly automation, compression pressure low, and combustion air supply is very low.
After burning, indication and effects. A rise in expansion line is recorded in the later part of piston stroke. Since burning of fuel continues, exhaust gas temperature and pressure increases, causing black smokes at engine's exhaust. Unburned carbon deposit fouls exhaust system, cause damage to exhaust valve and seat, turbocharger surge, and there are chances of uptake fires in exhaust gas economizer. Elevated temperatures inside cylinder cause breaking up of lubrication and increased wear of liners, piston rings, burning of piston crown, and etc. Ang mga causes: slow fuel combustion, quality of fuel is less, low temperature of fuel means high viscosity, and leaky fuel injector. So, ang indications and effects. So, reduced power in the affected unit, high exhaust temperatures, and presence of black smoke in exhaust. Possible knocking sounds or pressure waves in the fuel injection system. Suddenly up and downs in indicated diagram in the fuel injections and expansion side, and after burning due to incomplete combustions of fuel. Causes: leaking fuel injector, choking of fuel injector spray holes, which lead to improper automations and dripping of fuel.
On the left side is a light spring diagram comparing the normal, early, and late opening of the exhaust valve. If the exhaust valve opens early, this may be due to high exhaust temperatures and fouling of the exhaust system. This leads to loss of engine power. If the exhaust valves open too late, it will result to reduced blowdown effect and hence reduced scavenging efficiency. This may be due to the low quality of exhaust gas delivered to the turbocharger, affecting its performance. The picture on the right shows the light spring diagram when the exhaust valve is choked. We can see that the exhaust opens late and the scavenging process is very far from normal, and the compression pressure is much higher. This is usually caused by improper or incomplete combustion or maybe due to increased lube oil in the cylinder. This can lead to power loss, high exhaust temperatures, turbocharger surging due to little and high temp exhaust gas, and also affects the scavenging efficiency.
Next is the partly choke fuel valve. So, partly choke fuel valves occurs kapag yung fuel natin lalabas sa valve ay hindi niya na-attain yung pressure na dapat para sa kanya. That is why our valve is partly choke. This partly choke of the fuel valve occurs because of so many reasons. First is fuel contamination. Maybe our fuel is contaminated of some contaminants, or maybe our fuel is not, or there is an improper purification of the fuel. Second is carbon formation in the injector tip. And third is the carbon deposits on the valve due to overheating. And lastly is the low compression. Low compression occurs because of improper combustion, or there is insufficient air for combustion, or maybe there's a leakage in the combustion chamber itself because of the wear and tear of the parts. The indications that you are experiencing low compression is that you will have low engine power and low pressure in the indicator diagram. That's all, sir. Thank you.